Carl Pearson's coefficient of correlation. Here we denote this by the letter R, small letter R. Okay, small letter R is used to represent coefficient of correlation, small r. Then the formula to find this correlation is given by R is a first formula is R is equal to summation x minus x bar into y minus y bar divided by n into sigma x sigma y. Okay, so yesterday we defined what all these things are. So x bar means mean, y bar is mean of y, sigma x means standard deviation of x, sigma y is standard deviation of y, n is total frequency, how much summation of fy, that is n, total number. Okay, so this is the first formula to find the correlation. Now here this x bar, x minus x bar means we know x y will be given, you will find x bar and y bar, then we will find x minus x bar, then you have to find y minus y bar, then you will multiply these two, x minus x bar into y minus y bar, and finally sum of that will be taken, and then we can simplify it further. Okay, so while doing the problems I'll explain you how to do that. So this is the first formula, and actually this which is on the numerator, summation of x minus x bar into y minus y bar upon n, this means summation x minus x bar into y minus y bar upon n. This is termed by another name, this is covariance. Okay, covariance, this term, only this part divided by n, that is called as the covariance. Okay, so we are not going to use it anywhere, so we do. So is instead of this you can even write as covariance of xy divided by sigma x sigma y. This is another formula. Students or statistics students are using this also. So studying pure statistics, they use this formula and all. So covariance of xy upon sigma x sigma y, this is another formula for correlation coefficient. Then second formula is given by R is equal to summation, numerator will be like that only, x minus x bar into y minus y bar divided by this under root of, what we are going to do is we'll replace sigma x. Yesterday we defined sigma x is equal to summation of xi minus x bar the whole square divided by n. This is sigma x. So we will be putting this value, sigma x value will be put here, sigma y value will be put here. So you can say denominator root n into root n will come here. So that root n into root n means n will be there, that n and this n will get cancelled. Okay, so instead of putting sigma x sigma y, we can use this formula also. So that is summation x minus xi minus, so here x minus x bar into y minus y bar, or you can even use xi minus and yi minus. Okay, so if you use, no problem, if you do not use, then also no issue there. So here summation x minus x bar into y minus y bar upon under root of summation x minus x bar the whole square into summation y minus y bar the whole square. This is second formula. Now in some textbook you may find that if you are using old textbook, I think somewhere there is a printing mistake with a plus sign here. This is wrong. Okay, there is no plus sign here, this is into sign actually here. So it is into summation of x minus x bar the whole square into summation of y minus y bar the whole square, then square root of that one. So that you are getting from here only, from this part you are getting that. So this is the second formula. Then now in the same formula, let we use, say if x minus x bar, if I use x minus x bar is equal to say some capital X, then say y minus y bar we use say capital Y, then this R is equal, so all formula are getting from the previous one. R is equal to here summation, instead of x minus x bar I'll use x, instead of y minus y bar we have y, divided by, then here x minus x bar is replaced by x. Okay, so this will be summation x square under root of summation x square into summation y square. This is another formula. So this is one of the most repeated, used formula. This one, this third one. Okay. Now, so that is third formula. Now the other formula what you can write is, say, fourth one. This r can be written as, again, now what we do is we'll multiply this one, term by term multiplication, x into y, then x into y bar, then x bar into y, then x bar y bar. So by multiplying the numerator, okay, and then doing a bit simplification in the denominator, we have another formula which is, just a minute. So another formula, just by multiplying the numerator you will get it as, this is summation xy minus n into x bar y bar. This is also a most useful, used formula. Then under root of summation x square minus n into x bar square. Okay, so this will be here in bracket into summation y square minus n into y bar square. This formula we are getting from the shortcut method of finding the variance and all. Okay, so this is another formula, summation xy minus n into x bar y bar divided by summation x square minus n x bar square into summation y square minus n y bar square. And the other formula means this same formula we can again simplify like this. That is, if we use, if x minus x bar, which one, this one, this can be again rewritten as, if x minus x bar, suppose I write it as dx, and y minus y bar is equal to, say, dy, then r is equal to, that is this formula only, this one only. Okay, so here x minus x bar, if you write capital X capital Y, then you will have this formula. Now instead of this capital X capital Y, if you are using dx and dy, okay, so that is dx and dy, then that r will be given by summation dx into dy divided by summation under root of summation dx square into summation dy square. Why we are using this one? Because sometimes what we will use, we may be confused. Okay, you need to write small letter x, capital letter x and all. So in order to avoid that, if you are just using x minus x bar is dx and y minus y bar is dy, you are getting summation dx dy divided by root of dx square into dy square, like that formula you will get. Okay, so these these are the 5 formula which we know. Okay, now out of this one, it is your choice, you can use any formula. Then depending on the questions, sometimes if the terms numbers are very big, then and all you can use this method, this substitution and all. Otherwise, if it is small numbers, if the data is very small, you can use this first, second, third as you like. You can use any of the formula. Okay, so now using this, it will solve some problems.